Everyone, welcome back. In this video, we'll be discussing about the third problem of today's weekly contest, longest non-decreasing subarrays from two arrays. The problem is a bit interesting, and as always, we will start from scratch, the very brute force solution, and we will build a solution from intuition from there. This problem is a very good problem if you want to practice recursion or dynamic programming, and there are a lot of different interesting follow-ups to this problem as well. For example, what if instead of two arrays we have k number of arrays? Instead of subarray we have to find out subsequences. So if you watch the video till the end, I am very sure that you will be able to answer all those follow-ups by yourself. So with that, let's get started. The problem states that you are given zero indexed array nums1 and nums2, both of equal size n, and you have to define another indexed array, zero indexed array nums3 of same size, and for each index I you will either assign nums1 of I or nums2 of I to nums3 of I, right? So nums3 is formed of either nums1 or nums2, right? So the task is to maximize the length of longest non-decreasing subarray in nums3, right? So you have to return the length of the longest non-decreasing subarray. So let's take an example. Let's say nums1 is 231, nums2 is 121. So we have to form nums3 such that the length of longest decreasing subarray is maximized. So one way to form nums3 is we'll choose nums1 of 0, we will choose nums2 of 1, and we'll choose nums2 of 2. So we are choosing these two from nums2 and we are choosing this from nums1. So the final array would be 2 2 1. So in this, the longest non-decreasing subarray is this 2 comma 2, which is of size 2. So it can be shown that there can't be any non-decreasing subarray which is of greater than size 2, and hence the answer here is 2. Let's take one more example. Let's say the nums1 is 1321, nums2 is 2234. Again we have to form nums3 optimally such that the length of longest non-decreasing subarray is maximized. So here what they have done is they have chosen nums1 of 0 and nums2 of 1 2 3. So the final array would be 1 2 3 4, and you can see this is it. This entire array itself is a non-decreasing array. So we found out a subarray of size 4 which is non-decreasing, and hence the answer here is 4, because you can't get a subarray of size more than 4 because the maximum number of elements in the array is 4. So hope the problem statement is clear. Now how to solve this? So what is the brute force solution to solve this problem? We have been given these two arrays, and we have to build third array nums3 by choosing one of the elements from each of the indexes, right? So what you can say, okay, I will try out every possible nums3 and I will figure out the longest non-decreasing subarray in each of these nums3, and then I will just take the maximum and that will be the result. For example, what you can say that, okay, I will try out every possible nums3. So one such possible nums3 could be this, where you have chosen 1 from the first one, 2 from here, 3 from here, and then 1 4 4 from here. So you form a nums3 like this, and now you can say, okay, I will find out the longest non-decreasing subarray. So in this case the longest non-decreasing subarray is this 1 2 3 or 1 4 4. Basically the size is 3, and you will similarly figure out the size of the longest non-decreasing subarray for all possible nums3. Once you have figured it out, you take the maximum, that will be the result. So what will be the time complexity in the entire approach? The time complexity will be the total number of nums3 possible. So how many nums3 are possible? Again, what you are doing, you are choosing one of the two elements as the value in nums3. So in total there are 2 to the power n number of 2 to the power n possibilities of nums3. For each of these possibility you are trying to figure out the maximum non-decreasing subarray. So for that you have to iterate over the array once, and as soon as you encountered a non-decreasing subarray, you will break the current array and you will start a new array, right? So that will give you the maximum non-decreasing subarray. So that will take order n time. So in total, the complexity is 2 to the power n into n, which will surely not pass because n is up to 10 to the power 5, right? So we have to optimize this. Now, first of all, we can't, what does optimization here means? Optimization here means we can't iterate over all of the possible nums3. It means we have to smartly pick nums3. So what does it mean by smartly picking num3? Basically, we have to figure out whether we can skip some of the nums3 based on some criteria. So one possibility could be, you can say, okay, if I know the previous number, I can simply skip a possibility without a second thought. For example, let's say you know that previous number is 1, right? Whatever previous number you have chosen is 1. So from here, you can choose any of 2 and 3, right? Let's say you have chosen 3. Let's say you have chosen 2. So again, you know that previous number is 2, so you can choose any of 2 and 3. Let's say you have chosen 3 this time. Now you know the last number is 3, so what could you choose from here? Basically, the last number is 3 itself, so you know that whichever you choose will not make sense, right? So that's where what you will say, okay, this is the end of the first non-decreasing subarray and I will try out another combination, right? Similarly, you can say, let's say you have picked 3 here. So in that case, you know that because you have picked 3, there is no point in picking up 2 from here, right? So you can simply skip this part and say I will pick 3, right? So basically, if we know the previous element, we can make some choice about what should come next, right? So let's say you know the previous element, you know the last element, right? Now what are the choices for the current element? So once you know the last element, the previous index doesn't matter at all, because you can think that this is your new array. You can simply skip the last element, simply skip the previous element completely, and now you have to figure out what is the longest non-decreasing subarray such that the last element is L, right? So now from here, let's say you pick 3 or 2, either of them. Let's say you pick 3, right? So now you have picked 3. Again, because you have picked 3 already, you can simply skip this part and you can say, okay, what is the longest non-decreasing subarray starting from here, where the first element is greater than or equals to 3. So isn't this problem exactly similar to the previous problem that we just see? Previously we saw that, okay, what is the longest non-decreasing subarray starting from here such that last element is L. Now you are saying, okay, what is the longest non-decreasing subarray starting from here such that last element is 3 or 2. So hope you can see the recursion here. So what we can just say is, we will define a recursive function f, let's say, which have 2 parameters, the last value and the current index. So if we know the last value and the current index, we can simply try out the current, we can simply try out what should be the possible value at the current index and simply call the same recursive function to get the answer, right? So what would be the pseudocode look like? Pseudocode would look something like this. So what you are saying is, you have this last element and the current index which you want to pick for. So you'll say if last value is less than equals to nums1 of index, then you can pick nums1. There is no issue in that. So if you pick nums1, what will happen? You have last and then you pick this particular nums1. So next element should be, for the next element, the last element is this nums1, right? So that's what we are doing. We'll say for the next element, the last element is nums1 index, and I have to figure out what is the longest non-decreasing subarray that will start from index plus 1, right? So whatever answer you will get from here, you will just add 1 here because you have just put one extra element, which is nums1 of index. Now the second choice that you have is to see if last value is less than equals to nums2 of index. If that's the case, then nums2 of index is also a valid candidate. So you will do the same thing. You will pick nums2 of index after last, and for the next element, nums2 of index is the previous element. So that's what you will do. You will say what is the longest non-decreasing subarray starting at index plus 1, such that the previous element or the element should be greater than equals to nums2 of index, right? So whatever is the max of these two criteria, that will be your result, right? Now notice that you are trying to find subarray. So you have started your subarray from this particular index, but in result this might not be optimal. Your subarray might start from here, or it can start from here or here, and so on and so forth. So in this particular approach, you also have to make sure that you traverse all the subarray. So instead of just traversing the like starting from the first element, you will start from every other element. So you will say my starting index is everything between 0 and n minus 1. Now the first element can either be this or this, right? So we'll try both. So first we'll try out the first element as nums1 of start, and then we'll try out the first element as nums2 of start, and whatever will give us the maximum, that will be the final result. So just to reiterate this entire point, we've started with brute force 2 to the power n. We saw that that will not pass, and we have to optimize this. And optimization there means that we can't iterate over all the possible value of nums3, because it will contribute 2 to the power n to the complexity. So that's where we thought of making some observation, and we saw that if we know the last value, then we can make some smart choices about the current value as well. So why we are able to do that? Because we have to find out the non-decreasing or non-increasing. So because the value is completely increasing or decreasing, we are able to just depend on the last value. Otherwise we would have to depend on previous values as well. So because we can depend on last value, we saw that okay, we can simply define a recursive function that will give us what is the longest non-decreasing subsequence that will start at particular index I, such that last value is L. And we figured out that how to implement that recursive function as well. Now once this recursive function is implemented, what we also need to make sure is the subarray may not start from the first index always. It may start from the second or third or fourth index as well. So that's where we, in our driver code, we have tried out all possible combinations of the starting index of the subarray, right? So what is the time complexity of this entire solution? First of all, we are iterating over something n number of times, right? And inside this we are calling a function. So let's try to figure out the time complexity of this function first. So this function, inside this function we are doing some constant operation, so that will not contribute anything. So basically how many times this function is called, we are doing some constant operation there. Now we will surely memorize it so that we don't compute the same state again and again. So what the time complexity is now completely dependent on how many unique ways are there in which f can be called. So number of unique ways would be the number of unique values of last value multiplied by number of unique value of index. So number of unique value of index is n, right? And number of unique value of last val can be, let's say, x, where x is the maximum value in this array. So this is the overall time complexity of this function, x into n. And you might be thinking that okay, we are calling this function inside this loop, so the complexity is x into n square. But that is not true, because this x into n constitute all possible computation of f. So inside this function, when you call f, it means because you have already computed every possible f, whenever you call f, it will be an order 1 operation. So this for loop will be order 1 if given you have computed all the f's previously. So the complexity would be n plus x into n, or in other words simply x into n as well. So this itself, this is much better than 2 to the power n into n, but this will also not pass because the value of x is 10 to the power 9. right? Now we need to optimize this. So if you are following this channel for some time now, I am very very sure that you will be able to optimize some part of this x into n solution for sure. So notice this x into n is just the complexity of this particular function itself. So just try to remove this x, and I'm very sure if you are following this you will be able to remove it. Just pause and try to think for a moment. So hope you thought about it. The simplest thing you can do is because this x itself is 10 to the power 9, and anything of the order 10 to the power 9 will not pass any time constraint. We will, instead of x, will maintain the index of x, right? So the very standard trick, basically, instead of maintaining 4, we'll say the last element lies in nums1 at index 0, 1, 2, 3, 4, right? So instead of sending 4, I will send it 1 comma 4, where 1 denotes that the element was in nums1, and 4 denotes that the element was at the 4th index of nums1, right? So that's what we have done. We simply removed this last index, and instead of this we have introduced two things: last value array and the last index. The first one will denote which one among nums1 and nums2 this element belongs to, and last index will denote what is the index of that particular, what is the index in of the element in that particular array. So the conditions are same, we are doing exact same thing. Now instead of comparing everything with last value, what we are doing, we are comparing everything with the nums of last value of index at last index. And what is nums? We have just made another 2D array by combining nums1 and nums2. So if you pass 0, it means you are referring to nums1. If you pass 1, it means you are referring to nums2. So this is exactly similar to this algorithm, but the complexity is much better than the previous one. How? Because now the complexity will denote will be determined by number of unique values of these three values. So again, index can have n distinct values, last index can also have n distinct values, and last value array can be 2 only, because it can be either 0 or 1. 0 means nums1, 1 means nums2, or vice versa. So the complexity is order n squared now. This is better than order x into n for sure, but even this will not pass because the value of n itself is 10 to the power 5. So 10 to the power 5 square will not pass. We have to optimize this as well. Now, how to optimize this? Notice that what we are like, we have to remove one of these two expressions. Either you can't remove index because that is something you will require. Can you remove last index? Again, try to pause and try to think for a moment if you can remove last index, and if yes, how. So hope you thought about it. Notice this particular thing. What is the value of last index every time? Last index is exactly equals to index minus 1, right? In both the cases. Because that's true, and why it is true? Because we want to find the subarray, right? So we are sure that if previous element is x, the next element would be x plus 1, because this is subarray. Because of this fact, we can simply remove this index completely, and this last index, we can say that last index will always be index minus 1. So that's what we have done now. We have removed this last index completely, and we have replaced the usage of last index with index minus 1 everywhere. So now the complexity reduced to number of different values of index multiplied by the last value array, which is 2. So the complexity is order n now. So we have started with 2 to the power n into n, and we have now reached to order n. So if you have any doubts in any of the following approaches, feel free to post them in the comment section below. I will be happy to answer. But I would encourage you to code everything by yourself, because that will give you much better insight on how to actually, like, how these solutions are actually working, right? One more thing, if you are new to recursion, I would also encourage you to code the initial 2 to the power n into n solution as well, because that will help you actually understand how to figure out all possible combinations, right? So that is very simple recursion, but if you are new to that, that can be a good exercise as well. So finally, let's in the next section we'll look at the code. Again, I would encourage you to code it yourself first before looking at the next section. So the code is straightforward. What we have discussed, this is the function f that we have been talking about. This takes two things: the index, or the which array the last element belong to, whether it is array nums1 or nums2, and this is the index. Now if index is n, we'll return 0, otherwise this is simple memorization we'll do. If we don't have this value computed, we will do these two things, right? So we'll see if nums1 of current index is applicable, or if nums2 of current index is applicable. So instead of that, we have just like as we have mentioned that nums1 is now a combination of nums is now a combination of nums1 and nums2. So we just iterate over all the nums. It means we are iterating over nums1 and nums2 as well. And inside this, we will just see if the current element is less than equals to the previous element or not. If it is, it means it is a valid element. We will try out that combination, right? So after this, in this main function, what we are doing, we are simply iterating over all possible start index. So this j is the start index. And why we have to iterate over all the start index? Because we don't know where the subarray or where the best subarray would start with. So that's why we have to iterate over all possible start index. The entire complexity is again order n, as we have discussed already. Now comes follow-up. So there are few interesting follow-ups. First is let's say instead of only nums1 and nums2, you have k number of arrays, and you have to solve the exact same thing. You have to build k plus 1th array, which will be one of these, which will contain one of these values for each of the indexes, right? And you have to build this array such that the longest increasing subsequence is minimized. The exact same problem. So how to solve this? Again, I would encourage you to first pause and try to think yourself, because it is very straightforward. So hope you thought about it. The solution is very simple. As we have already depicted here in the code, we can simply make a subarray of or make a master array of all the individual arrays, and inside this we can iterate over all possible combinations. So the complexity will now be, instead of order n, it will be order n into k, because this can now go to order k, right? And inside this function, this for loop will now also be order k. So the complexity would become order n into k square, right? Again, this order n into k square can be optimized as well with some thought. How? Just try to convert this solution into bottom-up solution, and you will figure out. We have discussed multiple times in this channel how to convert top-down solution to bottom-up and how to optimize it further. So I would link one of the videos of the previous Leetcode contest where we have done exactly the same thing. I would encourage you to watch that and try to code the optimized solution yourself as well. Now comes the next question. The next follow-up is you have to find the longest non-decreasing subsequence instead of subarray. Again, this can be of two types. Either you can solve it with nums1 and nums2, or you can solve it with all the k number of k number of arrays. So let's start with nums1 and nums2, and the second one would be exactly straightforward, as we have discussed the previous solution as well. So we have to find out the subsequence instead of subarray. Again, we have already solved this in this video itself. I would encourage you to pause and try to think for a moment. Hope you thought about it. The solution is this exact thing. Notice why we were able to remove last index, because last index was exactly equals to index minus 1. And why that was the case? Because it was a subarray. That's where last index was exactly equals to index minus 1. But in case you have to find the subsequence, you can simply keep last index as well, and that's it. You will be able to find out the longest increasing subsequence as well. And what will the time complexity? Time complexity would be order n square itself. If there are two arrays, if there are more than two arrays, it would be k square n square if you follow this recursion path. So again, if you haven't understood any of these follow-ups yet, I would encourage you to watch the solution or the thought process of the entire solution of the original problem, and I am very sure you will be able to get these follow-ups as well. So hope you like the video. If you like it, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.